Okay, so quick number before we start. 85% of projects built using AI coding assistance right now, today in production, have security loopholes, exposed API keys, and redundant code.
Say that again? Because that's not a film stat. That's the majority.
Yeah, the majority, and which means the tools we are all relying on are quietly shipping in a way broken trust every single day.
Alright, that's a good enough reason to have a room full of people. Hi everyone, I'm Gauri.
And I'm Harsh. Today we are presenting Loom, an AI native software engineering workspace.
Not another rapper around a chatbot.
An actual workspace. Let's get into it. We'll walk you through it slide by slide, starting with the problem.
So, the iceberg. And honestly, once you see the name, you'll get why.
Everyone's coding with AI now, so Copilot, Cursor, Cloud Code, ChatGPT. At small scale, it's genuinely great. Ask for one function, one file, it nails it.
Right. But that's exactly the tip of the iceberg. The part everyone sees. The cracks show up underneath at the scale. Thousands of files, interconnected modules, business logic tangled across the layers.
And that's where the magic starts hallucinating context it doesn't actually have.
And on the slide, we break that underneath part into three specific problems. Want to take the first one?
Sure. So the first one is context blindness. When a larger project is in building, initially the complete project is built, but the context window becomes saturated. And after a while, the AI has no idea how to fix an issue that might be small or connected with many files. In a way, the lack of clear context blinds the AI from making appropriate and on point architectural decisions.
Oh, and here's the one I actually find the funniest in a bad way: generalization, not specialization. One model is trying to plan, reason, code, validate, and document all at once,
Yeah, and that's asking one person to be the architect, builder, inspector, and the technical writer simultaneously on a skyscraper.
nobody signs up for that job.
Nobody. And the third one would be no memory. In a new chat request, almost everything starts from zero. So it doesn't remember where the connection of a certain file exists. Everything is done based on assumptions, hence, it repeats mistake with total confidence.
Which is exactly how we land back on that 85% number from the top. Not a small bug, but an architectural trust problem,
So, the real question the slide leaves us with is how do you fix an AI's blind spots without slowing it down?
which is a perfect segue.
As we know the problem now we face, and before directly defining the solution, we want to explain our perspective on how we intend to solve these problems. So, these are the ideas that define a project.
The core shift here is simple to say, hard to implement. Instead of one AI trying to do everything in a single prompt response loop, Loom treats software development as what it actually is: a life cycle.
So, understand, plan, implement, validate, document. Each stage gets handled by a specialized agent, not one generalist pretending to wear five hats.
Wait, walk me through the team for a second. Who's actually in the room?
So, a team of multiple agents, each specialize in their own way. A front end agent, a back end agent, a database specialist. You get the point.
So it's less one AI pretending to be the whole team and more of an actual team.
Exactly, and the whole thing runs on four pillars shown on this slide. So, that is context understanding, task decomposition, validation handoff, and persistent memory.
So let's actually break each of those down because this is the part people usually have the questions about.
So, context understanding. This is where I'll correct a misconception that might arise about Loom. Loom isn't scanning your repo and directly moving to building stuff, and neither is it trying to reverse engineer or anything.
Right. It actually works the other way around.
Yeah, so the agent completely understands the prompt first. It passes intent, figures out exactly what needs to be built, and sets up its own working context from that before a single line even gets touched.
So The context is constructed from what you actually asked for.
Exactly, and part of that setup is deciding right there which agent handles what. So by the time planning starts, Loom already knows this piece goes to the code agent, this piece needs the tester agent, and this needs documentation after.
That's a nice segue into the task decomposition. Then, because that's the next pillar, it's basically that the same idea taken further.
Right, a high level request like add authentication gets broken down by an LLM driven engine into a graph of smaller subtasks with dependencies explicitly mapped.
And each of those subtasks get routed, not randomly assigned, but to the best matching agent pulled from a registry of 15 specialized capability profiles. Matter of fact, the user themselves can select the preferences of the agents as well.
Now, Gauri, the question that I think matters the most, what stops one agent's mistake from cascading into everyone else's work?
That's validation handoff. The third pillar. Every agent's output passes through a confidence scoring and contract validation layer before the next agent is even allowed to touch it.
So, successes get checkpointed and failures produce actionable retry hints.
And the fourth pillar closes the loop persistent memory. A separate knowledge layer records what every agent executed, decided, learned, with conflict resolution and propagation across the whole system.
So, the next time you ask it something, it's not starting from zero, it remembers the last time.
That's the difference between a tool and a teammate, right there. Okay, now the actual solution. This is where we get concrete about the trade offs.
Three direct traits. Problem 1, no task specialization or accountability. Our answer, capability routed multi agent decomposition with contract and confidence validation before any handoff.
Problem 2, no memory across runs. Our answer, a persistent embedding searchable knowledge store with conflict resolution built in.
And problem 3, the one people usually care about most, black box generation. Nobody wants an AI that just hands you code and says, trust me, our answer is a full IDE surface. Visible plans, task graphs, change surfaces per agent status, all exposed through inspectable APIs.
So you can actually see the reasoning and not just the output. Now the slide groups all of this into four functional pillars: intelligent context retrieval, multi-agent task orchestration, a validation pipeline, and knowledge persistence. Harsh, you've probably spent the most time on the orchestration piece. Can you please take us through it properly? Because I think that's the heart of the whole system.
Yeah, I would be happy to. So, multi agent task orchestration is really the engine room. So, once the prompt is understood and context is set up, the task doesn't just get handed to an AI, it gets decomposed into a dependency graph. Think of it less like a to do list and more like a project plan with arrows between the items. So, this subtask can start until that one finishes. This one can run in parallel with that one.
So there's actual sequencing logic, not just a queue.
Exactly, and each node in that graph gets matched against our registry of capable agents as earlier mentioned. So instead of an AI does everything, you get the planning agent handles this node, the code agent handles that one, the reviewer agent sits downstream of both. The orchestration layer is what's constantly watching that graph, tracking what's done, what's blocked, and what's ready to be picked up next.
And it's coordinating all of that live while the agents are actually working.
Live, yeah, and it's not a static plan that gets handed out once. If a subtask fails validation, the graph updates, dependencies get re-evaluated, and the orchestrator reroutes without needing a human to manually reassign work. That's really what lets the scale past one big prompt into something that behaves like an actual engineering team running in parallel.
Which loops us right back to the black box problem. That goes away because that whole graph live is something you can actually look at.
So the next slide is called key innovations and expected benefits. So if zooming out, it's really five things.
Higher code generation accuracy because the context comes from a properly understood prompt. instead of a guess. Lower token consumption because we're not stuffing irrelevant material into every request.
That's a cost story, right? Not just a quality story. On top of that, better scalability for larger projects and reusable organizational knowledge that carries across dev cycles instead of resetting every time.
And real productivity gains because planning, reasoning, execution, and documentation are automated together, not separately.
The slide actually lays this out as a 6 step ladder. If you're looking at it, understanding, intelligent context retrieval, multi agent task orchestration, knowledge persistence, a validation pipeline, and a scalable modular architecture.
6 steps, each one building on the last, not six disconnected features bolted together.
Exactly the point we keep coming back to.
All right. For the engineers and all the technical people watching, here's the tech stack. Let's actually name some names.
So, the front end's built on React, TypeScript, and White. The backend's fast API on Python, with Pydantic for validation and Uvicon serving it.
The data layers PostgreSQL through Superbase with pgvector handling the similarity search. For the AI orchestration side, the Grok API for high-speed inference along with Olama API for cloud LLM support. A LangGraph inspired approach for the graph-based multi-agent workflows and embeddings for the context understanding.
Redis for caching and checkpoints, Docker for consistent environments, and on the dev side, Git, PyTest, Alembic for migrations, structured logging, etc.
Solid, unglamorous production grade choices on purpose.
So, Gauri, to summarize the tech stack for anyone to understand, I would say Loom isn't a demo toy, it's meant to hold up and act out.
Right. So the last so lastly, the future scope. The future scope of Loom filters down to three main directives.
So, first is an AI agent marketplace, a community driven ecosystem where developers build, share, and monetize their own specialized agents, one click installable into any project.
So Loom stops becoming just our system and becomes a platform.
Second, always up to date knowledge, agents that stay synced with live verified documentation. So, you're not fighting hallucinated APIs from an outdated training cutoff.
And third, high quality models and deeper integration, plugging in whichever frontier models you trust, connecting Loom into your broader workflow, and letting it keep suggesting improvements and refining its own outputs the more you work with it.
So, three key features to lead Loom on an even innovative direction. Make this workspace smarter without making it less trustworthy.
So, let's close the loop on where we started. That 85% number.
The problem was never can AI write code? It clearly can. The problem is trust at scale, context, memory, accountability.
And that's not a prompting problem, it's an architecture problem. So, the next time you ask yourself whether you trust an AI to build your next big project,
The answer isn't trust the model more, it's give it a workspace that deserves the trust.
that's
That's
Loom.
Loom.